Hello everyone, it's your host. Today is August 9th, a beautiful Saturday, and I'm back to introduce another super interesting, trending article from the archive. Get ready, because this one is all about music and AI, which is like a totally awesome combo. The title is Embedding Alignment in Code Generation for Audio. And if you want to check it out for yourself, the goal is yeah, I know, it's a bit of a mouthful. So let's dive right in. Have you guys ever heard of live coding? It's this super cool performance art where people create music and visuals in real time by writing code right in front of an audience. They use special programming languages for music, like Sonic Pi. It's like watching a magician, but instead of a wand, they have a keyboard. Now, wouldn't it be awesome if an AI could help these performers? No, like an AI assistant that could whip up some code on the fly. This would let the artists focus more on the big creative ideas, instead of getting stuck on tiny details of the code. But here's the big problem, and it's what this paper is trying to solve. Let's say a live coder asks Amnon, a large language model, "Hey, give me 3 different cool drum beats." The one might generate 3 different chunks of code. And yeah, the code itself looks different, but when you play them, they might sound almost exactly the same. That's a total bummer for a musician, right? The issue is that the AI understands the code as text, but it doesn't actually hear or understand the sound that the code produces. It can't tell the difference between code that just looks different and code that actually sounds musically different. So this paper is all about bridging that gap. The researchers wanted to build a kind of map that connects the world of code with the world of audio. To do this, they used something called embeddings. You can think of embeddings as a way to turn something complex, like a piece of code or a sound clip, into a list of numbers or a point in a super high-dimensional space. In this space, things that are similar are placed close to each other. So, they took code embeddings, which capture the meaning of the code, and audio embeddings, which capture the characteristics of the sound. At first, they checked that there was a simple, straight line connection between them. If you tweak the code a little, does the sound change in a predictable way? And they found out, no. The relationship is way more complicated than that. So they decided to build a smart model to learn this complex connection. They built a neural network that could look at a code's embedding and then predict what the audio embedding would be. It's like teaching the AI to imagine the sound just by reading the code. To train this model, they needed a ton of data. So they took 28 sample programs from Sonic Pi and used a clever trick to automatically generate thousands of variations, but randomize things like the tempo, the notes, the instruments, everything. In the end, they had 5,400 pairs of code and the audio they produce. With all this data, they trained their model, and the results were amazing. They used some fancy metrics to measure how well the code and audio embeddings were aligned. Before training, the alignment score was super low, like 0.9. But after training, their best. That's like a 6-fold improvement. It means their model got way better at understanding the real relationship between a piece of code and the actual music it creates. So you might be thinking, okay, that's cool for live matters, but what about me? Well, this kind of technology has some seriously cool applications for everyday life. First, let's talk about video streaming services like YouTube or Netflix. Imagine you're a content creator editing a video. You could just do your editing software. Find me some background music that matches this dramatic scene. Using this alignment tech, the AI can analyze the video's mood and then generate or find the code for a piece of music that perfectly fits the vibe you're going for. How awesome would that be? Second, think about interactive learning. Let's say you're learning to code in a fun, interactive tutorial. As you write your code, the background music could change in real time based on what you're doing. You rewrite a really efficient piece of code, maybe the music gets more upbeat and exciting. This kind of audio feedback would make learning so much more engaging and fun. And third, for all the gamers out there, think about VAR and our games. The world's sounds. OP could be generated dynamically based on your actions. If you start building a complex structure in a game, the background music can naturally build in intensity and complexity. This technology allows the game to create a perfectly cinematic audio experience that's generated on the fly, making the virtual world feel much more alive and responsive. Now, how does this compare to other tech out there? Well, we have standard code generators like GoFile Copilot. These are amazing for writing all kinds of code, but they don't have this multi-model understanding. They can write code that looks correct, but they have no idea what it will sound like. The research in this paper is a huge step towards an AI that understands the output of code. It's like the difference between someone who can just copy a recipe and a real chef who can imagine exactly how the food will taste. Then you have audio synthesis models that can create music from a text prompt. These are also super cool. They usually just give you a finished audio file. You can't easily go in and tweak it. The method in this paper gives you the actual code. This is huge for musicians and creators because it gives them something they can edit, learn from, and make their own. It's a tool for creation, not just a finished product. So to wrap it all up, this paper is a really exciting step towards building AI assistants that can truly help with creative work. We're moving towards AI that doesn't just understand language, but also understands the art, the music, and the visuals we want to create. That's all for today, everyone. I hope you found that as fascinating as I did. This has been your host, San No Candy. Catch you next time. Bye-bye.